Question number 4. The requirement is to find the exact values of modulus W and argument W if W conjugate equals to the rational function over here. After that, we have to solve for A and B if this equation here is correct. Okay, since W conjugate has been defined as this equation, the first thing you do is to punch out the numerator using your GC. You should get an 8. The next thing you do is to punch out the minus 1 minus I to the power of 2 using your GC as well. However, you realize that this is not possible because you end up with an error. Now, whenever the GC gives an error, if you are working on complex numbers, do not give up. Solve it manually. Say, treat minus 1 as A and a minus I as B. So, A plus minus B to the power of 2 is A squared plus 2AB plus B squared. So, you should get a 2I. So, dividing an 8 by 2I, you should get a minus 4I. Hence, W equals to plus 4I and mod W equals to 4. The argument is also pi over 4, which is the same as, okay, my apologies, this should actually be pi over 2. There's a typo in here. It is pi over 2 because W is completely imaginary, meaning to say that it lies on the vertical axis, forming a right angle triangle with the forming a 90-degree angle with the real axis. So now we are supposed to solve for A and B in this equation over here. IW equals to e to the power of A plus IB. The first thing I would do is to take a ln on the left hand side and the right hand side. I am doing this because so as to get rid of the e. Simplifying the left hand side, you should be able to get a pi I plus ln 4 plus ln I. Okay, simplifying it further, you get a ln 4 plus pi I equals to A plus IB. Comparing the sides, when you're comparing the parts, a ln 4 would be A and a pi would hence be B. Done. Question number 5. The requirement is to solve for W and Z simultaneously. Okay, there's no trickery involved in this question. Simply set Z as equation 1 and sub-equation 1 into equation 2. If you simplify that, you should get a W squared plus W open bracket 5I plus 4 close bracket plus 10I equals to 0. Okay, solving quadratically where A equals to 1, B equals to 5I plus 4 and C equals to 10I, you'll be able to solve for W and then subsequently Z. Question 5 done. Question 7. Okay, we are given this equation whereby minus 2 plus 3I to the power of 2 plus lambda minus 2 plus 3I plus mu equals to 0. Our job is to solve for lambda and mu. Okay, my intentions are to open up the brackets and to set the left hand side as a function lambda comma mu and the right hand side constant. This is so that we can compare the parts subsequently. So step 1, open up all the brackets and shift everything that contains either a mu or a lambda to the left hand side like what we have here, and then everything else, to the left hand side and then everything else to the right hand side. Then you compare the parts. So the real part on the left hand side must equate to the real part on the right hand side, meaning to say mu minus 2 lambda must be equals to 5, and a 3 lambda must equate to 12. Since 3 lambda equates to 12, lambda equals to 4, and a mu equals to 13.